Okay, so we have the limit of s over 2s plus 1 as s approaches infinity. So I'm going to show you the proof behind it, how you get to it, and then the easy trick that lets you kind of bypass all this crap. But first off, what we're going to do is something you should have learned in trig. I don't know if you have or not, but it's polynomial long division. So what we're going to do, we're going to kind of split this up into two fractions. And, well, I'll just show you. So, because a fraction is just the numerator divided by the denominator. Pretty easy. So we have s in the numerator, and we have 2s plus 1, just long division. So we're just looking at the first term though. What do we multiply this first term by to get this? That's 1/2. So multiply by 1/2 up here. That's how we do division. 1/2 times this is going to give us s plus 0.5 or 1/2, whatever you want to write it as. And then we subtract, which negative s, negative 0.5, we subtract, we are left with negative 0.5. Right? So, since there's no s in here, and we have an s in here, it's going to get a little messy, so we're just going to say that it's plus negative 0.5 over 2s plus 1. So, we now have the limit as s approaches infinity of 1/2 plus a negative, which is a minus, 0.5 over 2s plus 1. And you can verify that this is true if you wanted to do a common denominator and multiply everything through, but it's a little unnecessary. Just take my word for it. It works. If you want to check it, go ahead. But now if we want to evaluate this limit's a lot easier than the original one, where you get an infinity over infinity. Now we have no variable in the numerator. So we can just easily substitute infinity in. Substitute infinity into 1/2. There is no s here. 1/2 stays 1/2, right? Plug it into this. Infinity in the denominator, but not in the numerator. This is going to be a arbitrary constant, 0.5 here, over an infinitely large number. So it is going to get infinitely close to 0, so we can define that as 0. So 1/2 minus 0 is just 1/2. So the limit as s approaches infinity of s over 2s plus 1 is 1/2. Now, this is the proof, and this takes a long time, and I'm guessing no one wants to do this on a test. So the easy rule to remember, and I can apply it to the next couple problems too. When you look at this, we have s over 2s. They are both to the same power. This is s to the first over s to the first. When your leading term, the first term, this is the first term, second term in a polynomial, and if we had s squared plus s plus 1, there'd be 3 terms. It's a trinomial. But when you look at a fraction, when applying a limit to infinity, it's the coefficient of the leading term in the numerator divided by the coefficient of the leading term in the denominator. So when you look at it, s, what's the coefficient? The coefficient is just 1. Since these are to the same power, they're going to increase at the same rate. And what do I mean by that? When you look at the graph of x to the first, x to the first, x to the second, and x to the third, you see how this, increases at a constant rate. There's the first derivative is a constant. This increases at a faster rate, and x cubed increases at a rate faster than that. So when you're evaluating something at the limit for infinity, when it's the same term over the same term, they're going to increase at the same rate. So the trick is to just divide. 1 divided by 2, 1/2.